Hello everyone, welcome to Engineering Explained channel. In this session, I am going to discuss working of steam turbine with animation. I'll show you here the first the working and later we'll discuss with the sketch how the working of the steam turbine is taking place. Later we'll see the animation of the working of steam turbine. The steam turbine definition will take first and later what are the components and the how it works. A steam turbine is a device that converts the thermal energy of steam into mechanical energy, typically used to drive electrical generators. It works by allowing high pressure steam to expand through a series of rotating blades, causing them to spin and transfer the kinetic energy to the turbine shaft, which is connected to the electrical generator. Steam generation. Steam is produced in a boiler using a heat source like coal, gas, nuclear energy, or biomass. High pressure steam. The steam is then directed into the turbine at high pressure and temperature. Turbine blades. The steam expands and flows through the turbine blades, causing them to rotate due to the force exerted by the steam. Shaft rotation. The rotation of the turbine blades spins a shaft which is connected to electrical generator. Electricity generation. As the shaft rotates, it drives the electrical generator producing electricity. Condensation. The steam used now at a lower pressure and temperature is then directed to a condenser where it is condensed back into water, completing the cycle. Key components and concepts. Rotor, the central rotating part of the turbine, including the blades and shaft. Blades Blades are attached to the rotor. They are designed to extract energy efficiently from the expanding steam. Shaft connects the rotor to the generator, transferring rotational energy. Generator that converts mechanical energy, that is mechanical rotational motion, into electrical energy. Condenser condenses the steam back into water, allowing it to be recirculated to the boiler. Here is the working of multi-stage steam turbine. Multi-stage means in order to extract the energy present in the steam efficiently, the multi-stage turbine is used. In the multi-stage turbine, it consists of the three stages. One is high pressure turbine, and another is intermediate pressure turbine, and third one low pressure turbine. Here, the steam turbine mainly used to generate the electricity where the steam is used as a medium of energy conversion. As we know that here the energy present in the fuel in the form of heat that is used to generate the steam of the water, and that steam contains the energy in the form of temperature and the pressure, and that steam is expanded in the turbine so that that will convert that energy contained in the steam into a mechanical rotary power, and that rotary energy connected to the generator, it will generate the electricity. And here how it is working means the steam from the boiler, it is allowed to flow through these nozzles. These nozzles will direct steam to hit the this turbine blades, and there that will act the forces on it, and due to that force the blades will starts rotating, that will turns the shaft, that will spins the that shaft, and thereby after the expansion it goes to the second stage, and that is designed to operate at that pressure, that is the intermediate pressure, and where again the nozzles are provided, then thereby nozzle again it will directed on the blades, and the rotor blades will be rotates, and the expanding of the steam will be taking place. Later after the expansion, steam goes to the third stage, and where there is a low pressure turbine where Again, the blades are designed to operate at the lower pressure, and that will operates, rotates, and thereby that conversion of the steam energy into the mechanical energy in that stage also taking place. In all the stages, the single shaft is connected, and these shaft speed are synchronized in such a way that the whatever the speed producing from all the stages will be same. And this design of the steam turbine in such a way that here the size as well as the pressure and the flow rate are taken into consideration while designing the steam turbine to maintain a constant speed to operate this electrical generator. In the electrical generator, it will be generating the electricity that will be utilized for the different applications to supplying to the grid. Like this, in the different stages, the working will be taking place. Here I'll show you that one, the single stage steam turbine animation. Here the steam is enter at the center, and where the steam is expands on both sides, in both sides where the varying sizes of the turbine blades are used. Instead of using the stages, different stages, here the varying sizes are used. And there the expansion of the steam will be taking place, which will turns the rotor, and later the turbine shaft what it will be there, and it will be connected to a electrical generator to the generate the electricity. And similarly, the how I have shown in the figure, the number of stages are used for the generating the power efficiently from the steam. Efficiency and consideration what are taken for the steam turbines are multiple stages. Large scale turbines use multiple stages. What I've shown in this figure, the set of blades we are going to use to extract energy efficiently while controlling pressure reduction. Condensing turbines. Most modern steam turbines are condensing turbines, where the steam is condensed back into water after passing through the turbine. It will be condensed, and that water collected will be supplied back to the boiler. That is recirculated. Rankine cycle. Steam turbine operate on the Rankine cycle, a thermodynamic cycle that involves evaporation, expansion, and condensation of steam, and also which will be supplied back to the boiler. Thermodynamic principles. The operation of a steam turbine is based on thermodynamics, where the expansion of steam causes a reduction in its temperature and pressure, which in turn drives the turbine blades to convert into mechanical energy. Here, the one form of the energy will be converted into the another form. The thermal energy present in the steam will be converted into a mechanical energy, and later that will be converted into a electrical energy. That is the thermodynamic principle. The conversion of the heat energy present in the fuel will be transferred to the steam, then steam in that the heat energy what present it will be converted into a mechanical energy. That is the thermodynamic principle used in the steam turbine. This is about the working of steam turbine, and also I am going to take the working of the steam power plant in further sessions. You can watch later also. Thanks for watching. If you like, share, subscribe and comment.